All right, please sit down when you get a chance. All right, we're going to start the late morning session. It's going to be 3 more talks. Our first talk is by Dan Rosenbaum. Dan Rosenbaum is on leave from the economics department at the University of North Carolina at Greensboro and is currently working as the senior economist of labor issues for the White House canceled economic advisors. Known for his work on NBA plus-minus ratings and the luxury tax, Rosenbaum consults for the Cleveland Cavaliers and in the past advised the NBA Players Association. Back in his glory days, Rosenbaum had the good fortune of playing for 2 national champions in baseball for LaPorte High School in 1987 and Division III football at the University of Dayton in 1989. Rosenbaum has a PhD in economics from the Northwestern University. So thanks a lot, Dan.
First of all, I want to point out Dave Lewin is Dave's here. He's my co-author. He's a junior at McAllister College. And I also want to point out that none of the institutions I'm associated with, in particular the Cleveland Cavaliers or the White House, should be blamed for any mistakes that I've made with this paper. The other thing is in the acknowledgments here, I actually pointed out this, thanking these PBR Metrics message board, largely because this paper was written to a large extent through posts on that message board, and what I've kind of done is collected a lot of those posts, and we're putting those into a paper. And so the main point of this paper is to kind of look at this idea that stats, statistical analysis is always going to be better than human judgment. And this is certainly a theme that's kind of went through a lot of work that's both in sports and not in sports. I mean, certainly the Michael Lewis Moneyball book, that was a huge theme in that book, kind of pointing out that statistical analysis could lead to decisions in baseball that were better than the decisions using scouts and other, forms of human judgment. Malcolm Gladwell, this is a theme in a lot of his writing, and certainly was probably the motivation for his review of Wages of Wins, which is a book that's focused primarily on looking at NBA decision making. And then David Leonhardt he worked on some of the keeping score columns for the New York Times, and also is their economics writer. This has been a theme in a lot of his work on sports, a lot of his articles on sports, but then also a lot of the stuff he talks about in economics. And I have this quote from an article of his in 2005 that, that kind of points out that academic research has showed that in a lot of different areas, such as diagnosing patients, evaluating job candidates, that the evidence seems to show that statistical analysis tends to do better at predicting things than human judgment. And, the quote at the bottom, that Thaler makes is, when a computer model is given the same information as an expert, the model almost always comes out on top. And this argument has been brought into the NBA world by a couple folks, and certainly the most prominent person to bring this argument in is Dave Barry and his co-authors with the Wages of Wins. And I mean, they've made the strong argument that if you look at salary data in particular and relate that to various box score statistics, you tend to find that points per game predict salary fairly well, and not a lot of other things predict salary very well. And so their argument is that that NBA decision makers primarily use points per game as their kind of evaluation method. Maybe I'll talk a little bit later more about this, maybe also a team adjustment. And then he points out in his book, he and his co-authors, that that in some sense is irrational, because what folks have tended to find that in the NBA, if you're trying to profit maximize, you're trying to get the highest profits for your teams, in general what you want to do is you want to maximize wins for a variety of reasons. He has some nice papers looking at that. And to maximize wins, you need players that do more than just score. And in particular, this is points per game, so it's not even capturing how efficiently you're scoring. It's just the sum total of how much you're scoring. the New York Times also lowered their standards and let this other guy write for them, and he made the same argument, that salaries are based mostly on points and a little bit on rebounds, but when you look at the things that seem to determine winning, that it's a much broader set of characteristics. And so what I'm doing here is I'm actually setting up the straw man that I'm going to knock down a little bit later on. So I actually get to be both the straw man and the person knocking down the straw man in this situation. And we really want to think about this quote that I have here at the beginning, and I'll say it again. When the computer model is given the same information as an expert, the model almost always comes out on top. But the key question here is you have the statistical analysts who are coming up with a production function, the way in which they think, various box score statistics or something else, how they produce wins, and you have the folks who are using human judgment to do the same thing, the scouts, the general managers, the coaches, and in general, those two groups don't have precisely the same set of information. And so this condition that Thaler lays out is rarely true in the real world. And so there's a very, very real possibility that the human judgment actually does better in NBA decision-making in particular. I would argue that's probably less likely to be true in baseball because I think the stats capture so much more of the game than they do in basketball, because in basketball you have a very difficult problem attributing credit for any given action. A point is scored and on a given possession, and you don't know whether to give the credit to the guy who scored the point, the guy who made the nice assist, the guy who set the good pick, or the guy who's sitting out in the corner and spreading the floor so that the other defenders couldn't come and help. And that's only on the offensive side. On the defensive side, it's even more difficult because we generally don't have very many statistics that capture what's going on the defensive side. And so if the statistical analysis analysts don't take into account all of these things, there's a very real possibility that they could actually do worse and then I'm going to show actually then some fairly naive models of NBA decision making. So let me talk a little bit more about NBA production functions. So when I first mentioned that I was going to do this paper on this message board, I said I'm going to look at NBA decision making. I'm going to compare that to I'm going to compare that to some advanced statistical models, and I'm going to see who does better kind of predicting things like future team wins and how the teams do when particular players are on the court. And I didn't lay out at all exactly how I was going to model NBA decision making. So I get a bunch, and I was pretty busy at the time, so I didn't check back for a little while. And then there were like 10, 15 posts after I come back of folks coming up with these really elaborate schemes and wondering if I was going to use these elaborate schemes to kind of model NBA decision making from team to team. And I said, and I had to come back and say, well, that's not what I'm going to do. I'm going to actually take these kind of straw man arguments that people make about NBA decision making, add a little bit to them, and see if those kind of naive models of NBA decision making, that the folks, that the statistical analysts say this is what we think NBA decision makers are doing, if those models actually do better or worse than the advanced statistical models. And so I'm going to look at kind of three different things to say that these are probably fairly good characterizations of NBA decision making. But in each case, I'm going to say these are probably lower bounds in the sense that, probably NBA decision makers are doing a better job than any of these, models are suggesting. One is a pretty obvious one, is minutes per game. I mean, if NBA decision makers are playing certain players more, it would make sense for, to use minutes per game as, as a metric. Points per game is the second one. I mean, that's certainly the one that, if you look at salary data, it would suggest that that's, a metric that would be, a pretty good one to use to characterize NBA decision making. And then NBA efficiency, it's on the NBA website, and it's also very heavily dependent on scoring, and it's basically a measure that adds up the good things and subtracts the bad things, but not in any very systematic or necessarily well thought out way. And so those are going to be kind of three measures that I use to characterize NBA decision making. The one twist I'm going to have is I think that it's a little unfair to say that NBA decision makers only factor in something like points per game. I think they distinguish between guys who score 20 points per game for a team that's in the finals versus a guy who scores 20 points per game, for a team that's only winning, 20% of their games for the season. And so what I'm going to do is I'm going to add in a team adjustment. And so what this is going to do is with each of these metrics, I'm basically going to make an adjustment. I'm going to add all those player metrics up for a given team, and then I'm going to make some I'm going to basically add in or subtract off something so that those the aggregated player statistics by team are going to perfectly predict not wins but actually point differential for the team. And so the team adjustment is going to kind of perfectly get right things at the team level, but it's not necessarily going to apportion credit for players within a team correctly. So the team adjustment is one sense in which I might be biasing myself towards giving the NBA decision makers too much credit. But in the other dimensions, I think I'm probably going in the other direction. And I think on net, this is, probably what I'm calling NBA decision making is probably something that's a little, they're probably actually doing a little better job than what I'm suggesting here. What am I going to compare them to? I'm going to compare them primarily to kind of three different measures. One is wins produced. And wins produced is a measure put out by Dave Barry in this Wages of Wins, and it kind of assumes that the team production function is applicable to individual players. And there's been a lot written on message boards and probably not in academics about how this is potentially a problem. There's also another issue with that metric that they kind of assume a different production function for the own team's production function versus the opponent's production function. And so those differential, and it's unclear why you would assume differential production functions for the team that you're looking at versus the team that they're playing. And it leads to some funny things with their metric that I might allude to a little bit more later. The other metric that I'm going to look at is the player efficiency rating it's John Hollinger's player efficiency rating. I think John's actually here. And I had to guess, since I knew he was going to be here, I had to be a little kind to him and say it's a more careful and reasoned weighting of the good and bad things. But the player efficiency rating is not, this is really, John kind of carefully going through and thinking about the game at the level of a possession and really thinking about how each box score statistic should be valued kind of per possession. But it's theory in the sense that, this is kind of John's, for the most part, this is, John's opinions about how these things, how important they are, and it's not data-driven in the sense there's not some regression sitting behind it that's, that's kind of given John guidance about what, the proper weighting should be. Wins produced is kind of, and then let me talk a little bit about adjusted plus minus, and I'll talk more about this in the next couple of slides. Adjusted plus minus is a completely non-box score statistic. It's going to basically measure how well the team does when a given player is in the game, and it has nothing to do with the box score. And so in a way, that is one that's completely driven by the data in terms of saying how good particular players are. Player efficiency rating is really kind of a theory-driven one, and that's probably how most player metrics are much more like the player efficiency rating. And then wins produced is somewhere in between. It has some components where some of the weights are actually determined by some regressions, but most of it is kind of also theory-driven. Let me talk a little bit more about adjusted plus minus. Again, it measures how the point differential changes when a given player is in the game, holding the effects of the other players on both teams, not just the opposing team, but on your team as well, constant. And so earlier I talked about how in basketball it's very difficult to apportion credit. Because when a given a point is scored or not scored, it's very difficult to figure out how to apportion credit. Well, in theory, since this is going to pick up how the team's doing when you're on the court, it should pick up pretty much all the contributions that a player makes, including setting a good pick, playing good help defense, spreading the floor. All those things should be in there. There's a few contributions that it doesn't pick up, such as a player like Shaquille O'Neal who generates a lot of fouls on players, and those players have to sit. Since I'm controlling for the players that are on the court, he's generating kind of worse players on the court throughout the game, both when he's in the game and when he's not in the game. That's not going to be picked up by this measure. But and also if there's players who have really good practice habits and spur their teammates on to to work harder during the off season and things like that, that's also obviously not going to be in here. The adjusted plus minus it's not widely used for a couple of reasons. One is it's fairly difficult to compute. I had to do this. I'm breaking down games into all the combinations of players in every game, and so this is 100, for both teams. So this is over 182,000 combinations, between the 2002-03 and 2006-07 season. And I think for the most part, a lot of statistical analysis, at least in the NBA, and probably to a certain extent in Major League Baseball and stuff at this point, is still primarily probably done a lot of times in Excel, and this is not something that's really that easy to do in Excel. Just to give you some sense of how this is done, this regression equation, this is, I think, probably when I'm done with everything, it'll be one of my proudest things, because this regression equation actually got published in Sports Illustrated. And so I think that I am the only person probably ever to get a regression equation published in Sports Illustrated. And they even down to the point where they said epsilon is an IID error term. They had all that stuff in there. Although they didn't think that there were quite enough Greek letters in the equation, because I didn't notice this when they kind of showed me the first copy of it, but all the X's were turned into chi's. And so the basic point of this equation is that what I'm measuring, so the unit of observation here is a shift in a game. So a shift in a game is defined by, there's no substitutions for either team. And so this is going to be a collection of, possessions for both teams where none of the players on either side change. And so what I'm measuring is I'm measuring over that shift the points per possession for the home team minus the points per possession for the away team. And a possession in this situation, we're defining possessions as a possession only, you only change possession when the other team gets the ball. So an offensive rebound, for example, does not start a new possession. To get a new possession, either there has to be a made basket, there needs to be a steal, there needs to be a defensive rebound. An offensive rebound doesn't start a new possession. So on average, in most typical situations, both teams have roughly the same number of possessions. The X's are individual kind of player fixed effects in a way, although they're not precisely fixed effects, because they take on the value of 1 if a player is at home and playing. They're equal to -1 if the player is in the game, but they're on the away team, and there's 0 otherwise. And then there's the error term. And so and then beta naught picks out the average home court advantage for all teams, and the other betas are, again, player fixed effects that measure how the team point differential changes when a particular player is on the court relative to the reference players, holding the effects of the other players on both teams, constant. And reference players are guys who, I don't want to try to estimate this for guys who've only played, 50 minutes during the whole season, so I just lump all the players who played less than 250 minutes in a given season all together. And so this is going to measure.
How can your error terms be
You mean, although remember I'm normalizing so it's per possession. So it's home points per possession minus away points per possession. So it's not, it's not going to be, if you've had a unit that's been out there for 20 possessions, you're not going to necessarily have a higher error term than, for one that's only been out there for 2. There's still potentially some issues there, but I don't think it's quite as bad as that. So I want to take a look at each of these metrics and do some and show you some correlations of these metrics with box score statistics to give you a sense of the of what's kind of driving each of these player metrics. And and implicitly you should be thinking about this. This is kind of showing you that there are different production functions behind each of these player metrics. And all of the statistics, all the box score statistics, points, true shot attempts measures both field goal attempts and free throw attempts, rebounds, assists, all of those are measured per 40 minutes, they're pace adjusted, and then more importantly, they're position adjusted. So they're measuring how you do relative to other players at your position. And what you see is that the 3 metrics that I'm attributing to NBA decision makers, minutes per game, points per game, NBA efficiency, all give scoring a pretty big weight. I mean, minutes per game less so, but certainly points per game, NBA efficiency are giving scoring quite a bit of weight. And you see that both with these, with the points and the true shot attempts. And notice points per game is not going to be perfectly correlated with points because that's points per 40 minutes. And points per game is a combination of minutes per game and points per 40 minutes. And so it's not going to be perfectly correlated with points per 40 minutes. John Hollinger's player efficiency rating also is very heavily correlated with points and scoring. I mean, it is very scoring dependent. You kind of see that with the very high correlations, for both points and true shot attempts. Wins produced, on the other hand, has a very low correlation with scoring relative to the other metrics, and you see that rebounding is extremely important for kind of determining, whether you're a good player using the wins produced metric. This alternate wins produced metric is really it's wins produced where I've kind of made the assumption that the own team that the production function for your own team is exactly the same as it is for the opposing team, and that leads to some slightly different weights. And what you see is that tends to increase the weight placed on scoring and lessen the weight placed on rebounding. And the other thing that I think is kind of interesting at looking at this table is that adjusted plus minus, if you look at those weights, if you had to pick another one of the metrics that, and remember, adjusted plus minus is measuring how the team's doing while a given player's out there on the court. If you had to pick one of the other metrics that kind of looks a lot like, it's minutes per game. There's a lot, the correlations of adjusted plus minus with the box score statistics is very similar to the correlations of minutes per game with the box score statistics. They're not identical, but they're similar. And that's kind of our first piece of evidence that maybe NBA decision makers are getting things right to a certain extent. Because, you're kind of seeing these very similar correlations. Because we kind of know adjusted plus minus on average is kind of, getting things right. There's going to be some issues with noise, which you're going to see here in the next. I'm going to talk a little bit, here next. Well, not quite next. So now the question is, how am I going to compare these different player metrics? How am I going to talk about which ones actually do the best? And one of the common things that folks have done is they've used these current metrics, they've aggregated them up, and then compared them to current team wins and see how well they explain current team wins. So you look at your player metrics for this season, aggregate them up by team, see how they explain current team wins. Well, the problem is if you have these team adjustments that I've talked about, the team adjustment is going to force every single player metric to perfectly explain team point differential. And team point differential is going to have, and so every single metric is going to have exactly the same explanatory power for current team wins. So a better experiment to do is to take each of these metrics, take the metric from the previous season, and then aggregate that up for the next season and see how well it explains the next season. So using the past season metrics, how well does that explain current team wins? And to do that, you have to make a few assumptions. You have to assume, first I'm going to assume that the metrics tell us, give us kind of per minute productivity for players. Second assumption is I don't want to try to come up with a model predicting how many minutes played every player has. So I'm just going to assume that we can do that perfectly. I'm going to do that for all the metrics. So that shouldn't bias me towards one metric versus another. I also don't want to deal with all the rookies and all the guys who didn't play very much in the previous season. So I'm going to assume all of those players are perfectly predicted as well. So and again, I'm going to do that for all the metrics. So again, that shouldn't really bias me towards any of these particular metrics. And so that's one measure I can look at. The other measure is I can use past metric. I can use these player metric values from the previous season to explain the current adjusted plus-minus ratings. And I'm going to actually find that this is a more powerful way to evaluate these team metrics, because the problem with using team wins is that it's a very blunt instrument to kind of measure the value of a player metric, because your identification is solely upon players who are changing teams or their minutes are changing. And if you have a team where they add one player who is kind of overrated by one player metric and another player who is underrated by another player metric, those things can offset, and you just don't have very much power using that method. You're going to see that with the results that I show here next. There's a lot more power in using the adjusted plus-minus statistics. And so here is in Table 2, we show the correlations of these player metrics with both team wins and with plus-minus. And I've actually ordered them in a rough way in terms of kind of how the metrics do in some combination over both of them. And John's going to be very happy. I expect this to be at the top of ESPN.com tomorrow. The player efficiency rating actually seems to do quite well. It doesn't do that well explaining team wins, but it does quite well actually predicting adjusted plus-minus. And I've set this table up. If you want to, the first thing you should look at when you see, one of the things you should look at here is these standard errors that I've also shown here would give you the impression that it's very hard to distinguish these different metrics statistically. But most of these metrics are very highly correlated between each other. So if you try to take the difference between two of these metrics and the correlations, you need to account for that correlation between the two metrics. And the standard errors of those differences are about a third smaller than the standard errors are actually just for the metrics themselves. And so a lot of these things are more statistically significant than they may appear here. And what I've done is I've actually bolded all of the player metrics that are statistically different than wins produced, and at the 1% level, and the ones that are statistically different at the 5% level are italicized. And what you see here is that two of the advanced metrics, wins produced and adjusted plus-minus, are actually do the worst of all the metrics on here. These are correlation. Well, technically, they're actually regression coefficients because we wanted to get the standard errors, and Stata doesn't produce standard errors but they're identical to what you'd get with regression coefficients. Just running correlation. The left would be team wins, and then these are aggregated up over the team. They're two different things in the two different columns. it's going to be the player efficiency rated aggregated up for the team, and that's going to be on the, that would be on the right-hand side.
So you want to be showing us R-squared as coefficients. You will make the statement something is more correlated than something else.
Well, but I mean, but the R-squareds are just going to be the squared correlations.
Exactly.
Right.
You want to show them. You said these are regression coefficients. These are uninformative.
Well, no, but we, I mean, but they're normalized. So they're, these are literally actually correlation coefficients, and then we got the standard errors by doing, by running regressions. And this is
what's the regression? What's on the left? What's on the right?
what's on the left is current team wins, and what's on the right are the past values of these metrics aggregated up.
And then this is the coefficient.
Yes.
No, that's not a correlation.
We normalize them all. We normalize them all so that so that you get exactly this from the regression. So if you normalize them,
Normalize stuff on the left.
right? We normalize them to mean zero standard deviation 1. So then these are exactly the same thing. Yes. And so what you're seeing is two of these advanced metrics actually do a much worse job than a lot of these naive assumptions. Naive models of NBA decision making. And in conclusion, because I think probably need to finish up here, this kind of gets me back to this quote by Barry where he talks about how, if you don't do statistical analysis, there's no way that you can understand what's going on in, in a basketball game. And I think the lesson from this is that, we obviously need to have better evidence before we make claims like this. But probably the bigger lesson is that NBA statistical analysis can make contributions, and I wouldn't be consulting for the Cleveland Cavaliers for free this year, but because I'm working for the CEA, if I didn't believe I could make a contribution. But we need to be careful when we do this because we can make things worse. If we write down production functions that don't capture the real production function very well, because we're having to abstract away from things that we can't measure very well, we have a very good chance of doing worse than models that are based upon using, Barry's terminology here, just staring. And so, I think the lesson here is that we need to be a little bit more careful in just assuming that statistical analysis is going to always be, better than than kind of just human judgment in a lot of these circumstances. So that's, and the only, I guess the last thing was, here are our top 10 lists for 2005-06 for the, for the 7 different metrics. So that's, are there any, I don't know if I have any time left.
Maybe a minute for questions, if anyone has any questions.
So I like adjusted plus minus, but it's too bad it doesn't correlate at all with team wins. So to do that, you did that on the individual level. You took Kobe Bryant, you took the Lakers wins, and Kobe Bryant's adjusted plus minus. You actually aggregate the adjusted plus minus of all the players on a team.
For the plus minus column, that's actually done at the individual level. That's done at the individual level because I can, I have a player metric from the previous season, and I can use that to correlate with the, with the player metric. With the plus minus. I should actually point one other thing out. This is the adjusted plus minus measured 1 year at a time. I've talked about in a lot of my own work that you can measure adjusted plus minus over multiple years. You can also use box score statistics to predict adjusted plus minus and then try to combine the two to come up with a better measure. I'm not showing you all of that stuff for probably obvious reasons. So you can do better with adjusted plus minus, but this metric, which I think is what the Dallas Mavericks and Winston Sagarin use, it's terrible. It's so much worse than the other models, it's embarrassing. Wins produced is bad, but that one's just terrible.
We should probably move on. Let's thank the speaker. At the end, we can end up asking questions after all the talks are over late in the afternoon, but just want to make sure we're moving along.